So friends, this is the fourth lecture of week 1, and here we will be discussing risk-based engineering. As I told you, risk-conscious operations management is one of the spin-off or further development of risk-based engineering. Only thing is, it is meant for operation ecosystem. So I am Professor Prabhakar V. Vardhe, and now we will see the only essential features of risk-based engineering, because it's a book what is directly relevant or what is required for initial understanding, that only I have put it. And as the topic our lecture follows, we will have more and more from risk-based engineering, and that time we will give you hint. So you can assume that this particular lecture is based on risk-based engineering, and this book is available in the market. Okay, if you feel like, and even the risk conscious operation management, this book is also available in the market, and if you feel like, you can have. Otherwise, these lectures also will be sufficient. Okay, so let us go to. Okay, so this is my book on risk-based engineering, which is forming the after PRA. The fundamental for risk conscious operations management. This was written in published in 2018. It is available with Springer or any other website that is available. So let us get started with what is risk-based engineering. Right since beginning, I have been telling you that there are two major approaches: deterministic approach and probabilistic approach. Okay, what is the integrated risk-based engineering framework? First, we have to define the problem. What is the problem? Okay, and then some element of deterministic and probabilistic and exchange among themselves. They will provide you a stage for integrated risk assessment. Okay. Like let's a simple example, deterministic criteria, failure criteria will come from deterministic only. It cannot be there from the plant configuration is defined under the deterministic side also only. Now, what will come in probabilistic? The true operating experience, that is failure of component, system availability, system reliability, human error probability, and then probabilistic fault tree, event tree. There are many more other models, Markov models. So they are part of the probabilistic component. Uncertainty analysis, which is very important. So in nutshell, if I have to say, the deterministic and probabilistic, they integrate and they support each other towards having integrated risk-based assessment or integrated risk-based engineering. Okay, and then when the model is developed, then validation with the deterministic and probabilistic goals and criteria, because every methodology or approach has their own goals and criteria. Deterministic might talk about the maximum temperature, maximum pressure, or like in terms of parameter or number of systems required, but probabilistic will talk about what is the goal at system level, at plant level, or even the individual component failure, what should be considered, what should not be considered, what is the test interval that is available. So all the quantified parameters will come here. So they provide a very elegant mechanism for risk-based engineering. Let me also discuss with you, there are approaches wherever deterministic, of course deterministic remains the prime approach for analysis, and the probabilistic approach either complement or supplement this system, and then it is like at least in regulatory domain, it is called as risk informed approach. But the experience suggests that both the approaches are required for having a holistic assessment of safety. So, and we have to use the strength of both the approaches. So, an integrated framework provides the holistic and complete model of the plant and understanding of the safety. And that is what has been proposed from this risk-based engineering book. And now we are discussing risk conscious operation management. So then validation and deterministic and probabilistic goals that we have done, enhanced monitoring, and so if any insight comes, whatever NS monitoring surveillance PHM is a new element. Probably directly it is not there, but indirectly it was there, like in terms of condition monitoring, certain other tools to assess qualitatively the remaining life and all. But actually the objective of PHM is RUL, remaining useful life estimation with acceptable uncertainty. Most of the industries, they have come up to the level of condition monitoring, preventive, corrective maintenance and all that. Now, safety and availability goals met. So, once the safety and availability goals are met, then we have say yes, and it is induction is integral to the system. It finds its application, rationals, reviews and all that. But if they are not met, redefine the problem. Either there is a problem side, there is any problem, or some what is lacking in anywhere. And when we have this framework, it becomes a very opportune and effective mechanism to go for risk conscious operation management. So, in nutshell, this provides the basis for risk conscious operation management, because human factor forms part of it, and that is where we are able to focus more or less on the this side actually. Okay. So, now before we go ahead, we just pause and discuss what is risk and what is risk characterization. So, this is one of the simplest figure or this thing, plant data and information. So, we have a plant here, and from there we have data, and we have to ask question what can go wrong and how frequently it happens. And if that is the case, then on other hand we have to ask what are the plant hazard potentials. And when we have frequency and we have hazard potential, it could be fatalities, it could be discharge into the public domain hazard, okay. And then we will say the risk for this hazard is this much. So, we get a statement of risk. So, this is a very simple, so here we get likelihood and here we get the consequences. Having done this, now we have a matrix here. Now, I have got a likelihood and consequences both. So, we can say if there are zones. So, these are prohibitive zones, red zones, because fatalities and frequency levels are high. But we can create this. What will happen is this matrix will provide a mechanism to focus on areas where we can do risk reduction. Okay. The second level is this one, amber thing is there, then yellow and green. These are the area which are rather relatively safer, and we have to focus on one, then second level, and then third, and then I think if and everything is based on resource that is available to us, and then finally, let's say risk targets. An example is risk to member of risk in the area of public domain. Actually, it should not be public domain, it should be actually plant damage risk. But if it is there, so we have to chase this target and we have to see how far we are complying with this situation. Let us say the older plants, they have a frequency permitted by conventional approaches are not permitted. I would say being followed is 10 to the power minus 4. Then we have a containment, and that can reduce this by a factor of 10, or accident measures it can bring it to this level, and then we will say risk to the member of public is less than 10 to the power minus 5 per year. And this is how, and what is risk? Again we saw so risk is nothing but adding all the events from 1 to n, like we did for our this thing, and likelihood and consequences we have to say. So, the consequences of hazard will expose to which area, number of people and all that, and then likelihood, what is the likelihood, that will give you totally a risk from the plant. So, now having discussed the this is very core part of risk characterization, it is many things, and as the lecture goes on, we will have things on other things. Now, from the risk conscious operation management perspective, what are the PRA qualities which percolate down through risk based engineering, which makes RCOM possible, are like this. first is quantification, we were told. So, quantification provides a very good mechanism for identification, prioritization, and optimization, and then second thing is integration. Integration of simple tech. We are able to integrate human factor into the main model of the plant. It's a big achievement actually, because it is being treated as a component. But again, the uncertainty is more, but integration we have done. Common cause we have integrated with the main plant. Then uncertainty characterization, that is quantified uncertainty characterization is possible only through the PRA approaches. Okay. So, we have that models, and we will see in later on this. And then rational based approach. Why rational based approach? Whatever I am saying top of the fault tree or event tree, I have got rational that I have done this. Now, if it is correct, well, if it is not correct, there it is subjected to modification. So, there is a documentation available, and it provides a rationale to do some correctional. So, everywhere rationals are important, and it gets reflected in the documentation or in the main model of the plant. Then human factor integration I mentioned here, and then the application. Actually, there is no doubt on this that PRA model offers application, and risk conscious operation management. We need application of this based on the risk as the component for our implementation. Like there are 3 systems waiting for modification. Now, which system is contributing more risk? You use that system. You first have that system. Second, similarly, there is a list of component, and there are component groups which are falling very arbitrarily. If you see, you will not be able to prioritize. But if your quantified method is available, you are able to use it for quantification. And then peer review. PRA really helps peer reviewers to see see what is going on, how it is going on, and how far it has been taken. Like even assumptions, if there is a way to document it. So, once you document it, then the reviewer can see in the light of those constraint and assumptions how far we are going. Elegant framework, fault tree, event tree, Marco, all the tools we used, Bayesian updating, they provide an elegant and I think quantification remains there. And finally, from here we have risk-based engineering, because there is a deterministic component also, and then there is risk-based engineering nothing but PRA plus deterministic, which I discussed in the previous slide, and we have a ORCOM, risk conscious operation management system in place. Now, let us talk, we are talking about risk conscious. What is consciousness? It has been adopted. So, if I have to develop a human model, my human model is like this, we have over here, and the input is external objects which are forming here. They are we have a sense based stimulus, and then we have a brain where cognition operates and conscience we operate, and it is assumed in this approach that our consciousness is a part of universal consciousness, because this we have picked up from the great books like religious book on Vedas and this thing, and the work which is going on in consciousness. Probably some elegant people, they are agreeing with this, but because we know that whatever we think, we reflect on something, and then it becomes the part of rest of the institution, organization, and then finally national and international. So, there is it's not exaggeration, and so consciousness we have here. Then when this human takes the model, the 7 sense bases and all that, seeing, eyes, smelling, nose, nostril, and then hearing, ears. So, these sense bases touch and all, and we have actions, and those actions, again reflection is there, it goes back. So, we operate in a closed loop. What are the symptoms of our actions or reactions? And when we discuss at the plant model, ORCOM model, the ORCOM model is, we have risk conscious culture, because we have a consciousness protocol. Probably it will be second or third lecture, and probably it is to redefine the human model or human factor model and all. So, officially we take into account, or officially or systematically we take into account the human considerations here. And then we have risk model of risk-based engineering. So deterministic, probabilistic, everything comes here, and it goes into the consciousness model, and risk conscious culture. It provides the fundamental for risk conscious culture. So we have risk, and finally it goes into the nuclear plant or whatever plant we are doing. I have given example of nuclear plant because my background is in nuclear. It could be any industry actually for that matter. And what is the outcome? Identification, optimization, prioritization, plant management towards ensuring risk to be as low as possible to the member of public domain, ensuring risk and reliability. So these are the desirable output that we wanted to have, and this is I would call it, this is a RCOM model for risk management, risk conscious management. Now, as part of RCOM, there is a methodology has been developed by me, and that methodology is it is called CQB model. Traditionally, the literature search, it suggests that human model either is not there in most of the human reliability approaches, or even if in one method it is there, there is a consideration of safety only, security is not there. So in this model, as I told you, conscience enters. Conscience take care of security part also, point number one. And there is a human model, that means there is a way to analyze the human or reach the root causes of human failure. Okay? So this particular flow chart, it shows organization and other things, and how we go on to doing develop CQB factors, faculties, mechanism, and corrective action program actually. So from here we have, so it is a basically and this has been done by using the fault tree technology. We'll see that thing once we come to that. I think it is here actually. So here you can see. So that human model, what I had reflected with sense basis and seven our sense basis here, and then how stimuli are formed and how perceptions are formed, and then finally conscience, that is it's like a gate, whether I should do this or not, ethically correct or not, and then that follows the action, and finally it reflects on the external environment around you, and then we have visible form the changes, and it again goes back to your sense base, and we operate in a closed loop. And whatever done here, it provides a formation, and then again consciousness and cognition. So most of the human reliability methods, we have cognition as the factor, but there is no explicit mention of consciousness. There could be a reference to focus, attention and all that, but a direct reference is not there, and consciousness is a consequence of, or rather it talks about, or it is a, so in this analysis we have assumed consciousness is a fundamental to human existence, and that's why consciousness is fundamental to this CQB method, or risk based engineering method, or risk conscious operation management. And finally, okay, so now here the human model. Now how we are trying to understand human model is made up of matter and spirit. So here we have physiology or body and mind consciousness. Let us not go now in material domain or non-material domain, Planck's constant. So physical body is internal and external. Okay, and then we have intellect center, and this fault tree goes into I think 35 or maybe 40 pages in the book. We go on doing, and finally we try to reach. No claim is made here that we have reached the root cause, but then this provides a starting point for understanding human. And when we spirit level, we take consciousness and conscience. Okay, and then finally consciousness, physical manifestation and implicit component, intuition, then life force, sources, and here we talk about in conscious, moral, attitude, ethics. So this is a basically top reference fault tree, and then there are many branches over here, because you can see 6, 7, 8, 9, so many in depth fault tree have been developed here. So we have two. One is the detailed human model. Earlier it was a crisp human model. Now we have this how to go down and try to understand, because the traditional method talks about the sleep, mistakes, and there are five or six items where we stop. But I think that we must go much detail into it, so that to understand. And then this is the formulation on CQB approach. This is the probability of non-performance is nothing but a stress ratio. So unlike time in many methods, here it is a stress ratio, because even if you are falling short of time, it is the stress which increases. So why not use a more fundamental parameter, stress? 1 minus conscience here. If it is 0 or 1, the equation goes off, and if it becomes 1, that is, conscience is full, perfect, then this equation comes into the picture. 1 minus P0, reference probability of failure, and exponential stress ratio divided by B factor, learning factor, and there are so many other factors. But at present we will just see this model. Later on we will have, if might get the opportunity, we will discuss this model also. And here we have overview. If I have to give you risk-based engineering, relevance of risk-based engineering to RCOM we have discussed. Human model we have discussed. Role of consciousness we have gone, because when we talk about risk consciousness, what consciousness means, probably that is important. And then root cause analysis, human root cause analysis, it is required, because it is a tool to we do for hardware the root cause analysis, and for human we come back to human error or some 2-3 word. No, that is not. We should go in details why human caused that type of, why it caused sleep, why it did mistake, what was the factor they had governed that thing, and further down, so that to understand the basic fundamental cause of human error.